Hello everyone. In this video, I'm going to share how to sketch the square root function and also determine its domain and range. Here we have a 10 example. I'm going to show the example 1. First example, I have function 1 over 2 square root of x. So we can always start from sketching the basic function. Basic function of the square root function is the y equals to square root of x, and this is the point. It passes through the 0 0, and it will go to the right hand side and go upwards. So when the function you have multiplied by 1 over 2, any function you start from is a basic function. If it is multiplied by a value which is less than 1, this is a value less than 1, then the graph will be a little bit less steep, and it will be like this. The graph will be having the same shape as the basic function, but the shape will be less steep compared to the basic function. It will look like this. It still passes through the 0 0 origin, but you can see that the gradient of every point will be a little bit less compared to the y equals to square root of x. So now you can label this as a y equals to 1 over 2 square root of x. If the question did not ask you to compare the basic function and the function given, you can just sketch the shape of the graph same as y equals to square root of x, because if the question did not ask you to compare, actually they are the same, because the point they passes through also the same and the shape also the same. What is different is the gradient between them. Okay, for the y equals square root of x, it will go up faster, and for the 1 over 2 square root of x, it will slower compared to the y equals to square root of x. After that, you can just erase this off. Now to determine the domain, you can see that the x start from the 0 until the infinity, because the point which is closest to the right is going to the right non-stop, so the x value will be represented by the infinity. And the range also the same. It will start from the origin, so the y start from the 0, and the graph is going up indefinitely, so it will end up with infinity. Okay. For this question, for this function, first I'm going to find the domain first by ensure that the inside the square root x minus 1 must be always greater or equals to 0, because the inside the square root we not allow any negative number inside the square root, so we must always make sure that the x minus 1 always greater or equals to 0. From here, I know that x must be always greater or equals to 1. Actually, you already got your domain. This is your domain actually. So from this domain, you know that the graph only exists start from 1, all right, and then it will go up to infinity. Okay, the shape will same as y equals to square root of x, but it will move 1 unit to the right hand side. All right, when you have x minus 1 inside the square root, if this is a negative 1, meaning that it will shift your graph. You will shift your graph. That is a basic graph. Originally, you have your basic graph y equals to square root of x. You shift your graph 1 unit to the right hand side. You will get this reference point from 0 0. You shift it 1 unit to the right hand side. You got 1 0, and then the shape will follow back the basic function. Now you can just label this as a y equals to square root of x minus 1. To get the domain, we already got the domain actually. Now we just convert this x greater or equals to x greater or equals to 1 into the interval, that you can see that the graph start from the 1 and up to infinity, because the graph is going to the right side non-stop. And for the range as well, you can see the lowest point of your graph is having the y value 0, so your range will start from 0 and up to infinity. Okay. For the third function, all right, we can see that we have the graph 4 plus square root of x. Now you can have your y equals to square root of x first. That is your basic graph. And now your graph square root of x plus another 4, meaning that your graph will be shifted 4 units upwards. That from the 0 0, you go up for 4 units. So now your starting point of your graph will be 0, 4. All right, and then the shape still will be remain unchanged. So this is the shape of the graph. You can just label this as a 4 plus square root of x, and after that delete the basic graph. All right, so this is your graph, and now you can get your domain. The domain is the point which is closest to the left, and it has the x value 0. So the domain is start from 0 and to the infinity. For the range, the point which lowest at the graph is this point, and it has the value of y4. Then the range will start from 4, and the graph at this point, at this endpoint, you can see it go up non-stop. So the range will be end up by infinity. For this function, we know the graph, we can start to sketch the graph of y equals to square root of x first, and then y equals to square root of x plus 2. So at this point, at this graph, we know that the graph will be either shifted left or right side. All right. If we've forgotten either shift to the left or right side, we can always find its domain by letting the x plus 2 go greater or equals to 0. From here, you know the x is start from the -2 and to infinity onwards. So the graph will be start from -2. All right, this is the starting point. And then after you sketch the graph of a square root of x plus 2, you may proceed to the negative of a square root of x plus 2 by reflecting about the x-axis. So now I'm at the second stage. This is my second stage. I try to sketch this graph. I know the graph from the basic graph. This is the basic graph. It shifted 2 units to the left side. I got this. All right. And this is my y equals to square root of x plus 2. Just delete your basic graph. And after that, I want to go to proceed to my third step. That is y equals to negative square root of x plus 2. When the function of y you multiply it by negative, meaning that the graph will actually reflected about the x-axis. So you will have the shape like this. Okay, this is your starting point. And delete the graph of square root of x plus 2. So this is your graph of a y equals to negative of square root of x plus 2. Okay, so this endpoint you can put the arrowhead to show that it goes to the right side. And now you can see that your graph is actually passes through the y-axis. You can get this value by substituting x equals to 0. Putting the x equals to 0, this you will have a negative set of 2. To get the domain of this graph, of this function, the domain, you already got it just now. You just need to convert it into the interval form. That is starting from the -2 to infinity. Or you can got this from the graph that you have sketched. And the range as well, you get a value, the lowest point for your graph. This is the lowest point of the graph. You can see the y value can represent by the negative infinity because the graph is going down. Yeah. And then the highest point of the graph is this point, and this point having the y value 0. So the range will be negative infinity to 0. So you have a square root of 3 minus x. Firstly, I will get my domain first. So solve for this inequality, you get the negative x greater or equals to -3. And then now to get the x, I will multiply both sides by -1. For an inequality, if you multiply both sides by -1, then the sign of the inequality, this is greater, right? Originally, this is greater. Now you have changed it into the less than or equals to. Okay, so this is a x less than or equals to 3, meaning that your graph will be start from this point. Okay, 3. And if you see the coefficient of x is negative, right? Then you know that the graph will be reflected about the y-axis. Originally, you have the basic graph like this, right? This is your y equals to square root of x. If you see that the coefficient of the x is a negative value, right? You must know that the graph is in this shape. Actually you are using the y equals to square root of x, you reflected about the y-axis, you got this shape. And this is a starting point. So where does it start? You will refer to the domain that you got it just now. Because the x is less than or equals to 3, meaning that this is a starting point. All right. So this is a 3. This value is a 3. Your graph will be look like this. Okay, sorry. It should be steeper a bit. Okay. Then you delete your basic graph. this point, this endpoint, you can put arrowhead to show that it goes to the left and go upwards non-stop. And now you can label this as a y equals to fx. Okay, so this is the, again, is a point which is you need to find it out because it's a y-intercept. Just put your x equals to 0 inside, you got a cert 3. So to get the domain of the function, okay, you just got it just now. That is from the negative infinity, because your point which is closest to the left is this point, and you can see that this point going to the left non-stop, and the x value that can represent this point is negative infinity. And the point which is closest to the right side is this point, and it has the x value 3. So this is your domain, and the range will be the lowest point. Lowest point of your graph is this point, and it has a value of y0. So the range will start from 0. And this is the other highest point of the graph. So the highest point of this graph, the y value can represent it by the infinity. Okay. For the next example, okay, I need to sketch the basic graph first. This is my basic graph. And then followed by the y equals to 3 over 4 sort of x. All right, and when you multiply this function of my basic function with the value which is less than 1, meaning that your graph will be a little bit less steep, okay, which I would say the gradient will be less. Okay, so when you sketch a graph, this will be the one. This is a y equals to 3 over 4 square root of x, and the basic graph, you just delete it. After that, followed by -2. So now your graph proceeds to the y equals to -2 plus 3 over 4 square root of x. So now you have the 3 over 4 square root of x. You need to take this graph, go down for 2 units because of the -2 over here. So you go down for 2 units, 1, 2. This is my reference point. Now it will reaching the -2. Okay, so this point will become like this, and the graph will be same shape as the 3 over 4 third x, only that we translate 2 units to downwards. So now you can just delete this and label this as your y equals to fx. You can see now you have a very important point, that is your x-intercept. You always can get your x-intercept by putting your y equals to 0. When you have a y equals to 0, you solve this, you have your 3 over 4, square root of x equals to 2. So square root of x equals to 8 over 3. All right, 8 over 3, yes. Then x equals to 16 over 9. All right, so this point will be 16 over 9. Now we need to get the domain of this graph. The domain actually is, okay, this is the point which is closest to the left, and it has the x value which is 0, meaning that our domain will start from 0 until infinity. And the range, the lowest point is having the value of a -2, so our range will start from -2. And this point, this endpoint, the arrowhead shows that it go up indefinitely, so it will be end up by infinity. Okay, I need to make some correction here. This will be 64 over 9. Sorry, 64 over 9, because you square both sides. You got the 8 square, that will be 64 over 9. All right, just delete this and change it into the 64 over 9. For this function, I'm going to get the domain first. You have a 4 minus s greater or equals to 0. Okay, always make sure that what is inside the square root must be always greater or equals to 0. And when you solve for this, you get the x less than or equals to 4. Means that our x will be from negative infinity until the 4. This is our domain. Okay, then now we can see that we want to start the graph from the y equals to square root of x, which is our basic graph, and followed by the y. Okay, this is my first stage of the graph. Second stage, I will try to sketch a y equals to square root of 4 minus x, and followed by the third stage will be the negative of this graph. It will be happen when you do the reflection. And lastly, I will shift the graph upwards for 1 unit to produce this graph. Okay, so firstly, we have this, right? Second stage, we have a square root of 4 minus x, meaning that you can see that the coefficient of the x, right, is -1. So the graph will be having the shape like this. It will be reflected about the y-axis. Okay, this is the shape of the y equals to square root of x. When you have the coefficient of the x is negative, meaning that it will go towards the left hand side and going upwards. Okay, but what is this point? You need to find it out here. This point it actually can be found by using this domain. The domain shows us that x must be less than or equals to 4, right? Okay, so we know that this is equals to 4, meaning that the graph will be actually reflected about the y-axis. You have a y equals to square root of -x, and from here it will go to the right hand side for 4 units. So as if that this is a 4, from the 0 0 it will proceed or shifted to the right hand side for 4 units, and our graph will become like this. Okay, so you can erase this off. Now you have the graph of a y equals to square root of 4 minus x. After that, you're going to negative multiply all the function, or multiply this become negative of the square root of 4 minus x, meaning that it will happen when you did the reflection. When this graph is reflected about over the x-axis, you will have a negative square root of 4 minus x. So when it reflects about the x-axis, it will become like this. So this is the graph. Okay, this is a graph y equals to negative square root of 4 minus x. Then erase this off. Then followed by the third graph, you have a negative square root of 4 minus x plus 1, meaning that at the third graph, okay, at the stage 3, you add 1 unit, meaning that your graph now will shift it 1 unit upwards. So I will take this as my reference point. Originally, this is a 4 0, right? So now it go up for 1 unit, become a 4 1. This is 1. Okay, so the graph will be having the shape same as this shape. Okay, it will be like this. Okay, so now you can erase this graph off, and the green graph will be actually your y equals to fx. And this is an important point. You need to find it out, where you can substitute the x as 0. Put the x as 0, you will have a negative third 4 plus 1. Okay, negative third 4 plus 1, third 4 will be 2, right? So negative 2 plus 1, you will have a negative 1 over here. Now to get the domain, the domain already given over here. Just now I have converted into the interval form. This is from a negative infinity to 4, and the range, taking the lowest point of the graph, this is the lowest point, and having the y represented by negative infinity, going to the up, the highest point of the graph, having the value of y1. So it will be stopped at the 1. For this function, we can see that the domain, it will be restricted from in between -1 and 3. But just ignore the domain first. We just sketch the graph as usual. Start from the y equals to x. This is your y equals to x. Square root of x. And then followed by the y equals to square root of x plus 1. By shifted 1 unit to the right hand side, to the left hand side. Yeah? You always can ensure that your graph is either going to the left or right by finding the x plus 1 greater or equals to 0 in order to find its domain first. So from the solution of this inequality, you can see that the x is always greater or equals to -1, meaning that your starting point will be at the -1 here. Okay, so the graph of the square root of x plus 1 will follow back the shape of this graph, but it just shifted 1 unit to the left hand side. Okay, you can just sketch the graph, and then followed by the third graph is taking the square root of x plus 1 and then add 1 unit, meaning that your graph will be shifted 1 unit upwards from the -1 0 over here, shifted 1 unit upwards. You will have somewhere here. This is your 1. Okay, This point will be having the coordinate -1, 1, and the shape will still remain unchanged. Okay, so you can erase this off, and now you can just okay, then we can see that the domain, they want the domain from -1 to 3, right? So this is a -1. You have done this, -1, meaning that your graph will start from this point, -1, up to 3. All right, up to 3. And this dense circle, you need to erase it off because we don't want to include the -1. So you need to change this by putting it as a empty circle. Okay. The same over here, you put an empty circle to show that it's not include the 3. After that, I will just highlight it with my green color and erase everything excess. Okay, so one important point you need to find it out, which is your y value for the x equals to 3, because this value is important for you to determine the range. Okay, so when x equals to 3, you just put it x equals to 3 inside 3. You got the square root of 4, which is 2. 2 plus 1, that will be equals to 3. So when x equals to 3, y also will be equals to 3. So this will be 3. Okay, so now you already done the graph. You can just label it as a y equals to fx, and followed by finding its domain. The domain already given over here, which is a start from -1. Oh, sorry, in between. This is not here. Sorry. This is what we found for the graph sketching, and the domain we need to refer to this one. Okay, the domain already restricted in between -1 and 3. So you cannot use the close bracket. You need to follow exactly given over here. Since this is your domain, and the range as well. The range you need to follow the domain, which you can search. You can determine the range by looking at your graph. The lowest point of your graph is this point, and it has a value of y1. And the highest point is this point, and having the y value 3. Both is not included, so the range will be in between 1 and 3. There is an important point need to find, that is your y-intercept. By putting the x equals to 0, you will have a sort of 1 plus 1, that will be 2. You need to label this. So now we move to the second example, the example I. Okay, to sketch this graph, first I will start from the y equals to square root of x, and followed by the y equals to square root of x minus 1 by shifting my basic graph 1 unit to the right side, and then followed by the negative square root of x minus 1 by reflecting this graph about the x-axis. So your basic graph is in this form. And now you want the square root of x minus 1. Your basic graph will be shifted 1 unit to the right side. You will have the same shape as y equals to square root of x, only the reference, every point of your graph will be shifted 1 unit to the right side. Or you may, to ensure this happen, actually you can letting this x minus 1 greater or equals to 0, you solve it. You get the x greater or equals to 1, means that your graph only exists start from 1 until infinity. And now we erase this off. You can now label this as your square root of x minus 1. Okay, so now we go to the last stage of the graph, that is obtaining the negative square root of x minus 1, which you will reflect this graph over the x-axis, and you obtain this. Okay, so this is your graph of a y equals to negative square root of x minus 1. And the graph that you draw, that you sketched just now, can be erased off. Okay, so now we are going to take care of this domain. The domain says that it wants x greater or equals to 1. Okay, so we might check our domain, the graph that we sketch. Is it the tally with the domain that requested by the question? Okay, then yes, as a domain that we found just now is also the same as stated by the question. So now you can put the arrowhead over here to show the graph is going to the right and going down. Okay, so now done our graph, you can determine the domain. The domains follow the question. You always have a 1 to infinity. and the range, you find the lowest point of the graph. This is the lowest point and having the y value negative infinity, and the highest point of the graph having the y value 0. So this is your domain and the range. All right, this is the last example of this video. I'm going to start from the y equals to square root of x, okay? And then multiply by 2. Actually, you can represent this as your 2 square root of x, because the 2 square root of x and square root of x, if you are not going to compare them, actually, when you sketch them, they look like the same. Okay, and then minus 4, meaning that this graph is going down for 4 units. It will go down. This is a reference point, and then I go down for 4 units. I will reaching the negative 4, 0. Then the shape still will be remain unchanged. Okay, so this is your y equals to fx. I can erase this off. Okay, to get your domain, you can looking at the graph, the domain will be starting from the 0, because this is the point which is closest to the left, and having the x value 0 until infinity. And the range, we find the lowest point having the y value negative 4. Okay, and then this endpoint showing the graph is going up indefinitely, so it will end up by infinity. And this point is an important point. You need to find it out by letting the y equals to 0 and solve for the x. Okay, then you have your 4 divided by 2, which is square root of x equals to 2, and x equals to 4. So this is the value of 4. All right, thank you for watching.